Welcome to notes 12.1, 2, and 4. In past units, we have talked about two-dimensional objects and their perimeters and their areas. Now we're going to be moving on to three-dimensional objects and their surface area and their volumes. And today we're going to specifically talk about prisms. So we're going to begin with a couple of definitions. First, we have a polyhedron. And a polyhedron is a solid bounded by polygons called faces, and it encloses a single region of space. So what that means is, if the faces of a polyhedron are polygons, polygons, you remember, are closed plane figures with three or more sides. So we are not talking about circles, anything rounded. They must have straight edges. Speaking of edges, an edge is a segment formed by the intersection of two faces. So, for example, where two faces of a box come together would be considered an edge. A vertex is an intersection of three or more faces. It is a point. And then let's talk a little bit about nets. So nets are two-dimensional representations of 3D figures. So 2D reps of 3D figures. And you can think about it, they're like patterns for a polynomial, not a polynomial, sorry, for a polyhedron that you would print out on a piece of paper, cut out, and then fold to turn into that three-dimensional figure. So let's draw a net for a cube with a side of 6. I'm going to cheat a little bit and use my shape tool because I'm a terrible artist. Okay, so when I draw nets, I like to draw the lateral faces first, which are all the faces not including the bases. So for a cube, there are 4 lateral faces. So I'm going to draw my 4 faces, and then I'm going to copy them so they're all exactly the same. I realize you can't do this, but just follow along with me here as best you can. All right, so there are my 4 lateral faces, and then in a cube, all the faces are the same, so I need to do my top base and also my bottom base. And those can go anywhere as long as they would go on top and on bottom of the figure when you folded this all together. All right, and then it says that it's got a side of 6 units, so we need to make sure to label our congruency markings and our dimensions. So in a cube, all the edges have the exact same measure. So we're going to go ahead and do congruency markings for all of our edges. And since they're all congruent, we can just write the 6 units one time. And that is the net of my cube. Okay, it gets a little more difficult when we're talking about a pentagonal prism. Now we name prisms by their bases, so if it's a pentagonal prism, it's got a pentagon at the top and the bottom, and then the number of lateral faces will be equal to the number of sides of the base. So since this is a pentagon, and a pentagon has 5 sides, there are going to be 5 lateral faces. So I'm going to draw my lateral faces. And these can be, you know what, let's do it with a rectangle this time. Issues this morning. All right, so you can see that the lateral faces can be rectangles as well. All right, so there's one, and then I need to duplicate that. So 1, 2, oops, gotta go back to my original, 3, 4, and 5. All right, and then I need a pentagon to go for my bases. So let's draw us a little pentagon that's about the right shape. Okay, so one at the top, and then I need another one on the other side of my lateral faces. Okay, and then we need to, of course, label our figures. So the height of my pentagon, or my pentagonal prism, is going to be 5 units. So my height here, height is always the distance between the bases. And so that is going to be 5 units. And then my side length is going to be 4 units. So these guys right here, these are regular pentagons, are going to all be 4 units. I get a lot of those. So we have to mark them all. if when I ask you to draw nets, you do not show congruency markings and you do not label them, so let's just label this one here, with the correct measures, you will not get the points. All right, so how could we use a net to find the lateral and the surface areas? Lateral means area of all the faces. Surface area means the area of all the faces. So lateral is lateral faces, and surface area is all the faces, including the two bases. Well, we know from past units how to find the area of a square, or how to find the area of a rectangle, and how to find the area of a pentagon. So we can just find each of the individual areas of these two-dimensional figures and add them up to find all of the lateral and surface areas. All right, let's talk about some formulas that you are going to need to know. You're going to need to have them memorized. First is for a right prism, and a right prism is just a prism in which the lateral faces are perpendicular to the base, and those are the ones that we're going to be talking about in this class. And so my lateral area, which is the area of just the lateral faces, is perimeter times height. So we'll say that lateral area equals perimeter times height. This P should really be a capitalized P because it's referring to the perimeter of the base. And height, again, is the distance between the bases. And then we use these two interchangeably, surface area or total area. So my surface area is simply going to be my lateral area, which was perimeter times height, plus 2 times the area of the bases. All right, all I'm doing is taking the lateral area that I already found and adding the area of the two bases to it. And then my volume, I can't move my little pen thing. Okay, my volume is equal to the area of my base times the height of the prism. So these are the 3 formulas that you are going to need to memorize for today. Now this next thing is not in your notes, but it is something that's important to know. And so I've included a little aside here. There are 5 Platonic solids. Now, Platonic solids are solids discovered by Plato, and they're solids in which the faces are all regular polygons. So, for example, in a tetrahedron here, tetrahedron has 4 sides, and each of the sides is a regular triangle. In a cube, which we are actually going to call a hexahedron, okay, there are 6 sides, and they each are formed by a square. In an octahedron, there are 8 sides and 8 faces, and they are formed by regular triangles. In a dodecahedron, there are 12 faces. Okay, so this is what we're concerned with. We're concerned with the number of faces. And they are all regular pentagons. And then in an icosahedron, there are 20 faces, and they are, again, formed by regular triangles. And this may come back at some point to haunt you, if you know what I mean. Now, if you look at the relationship between the vertices, the edges, and the faces, you'll start to see something interesting crop up. And it may only be interesting if you have a lot of time on your hands and you have nothing else to do, which apparently there was a mathematician who met that criteria. But what he found was, if you add the number of vertices plus the number of faces, so for example, in my tetrahedron, if I added 4 plus 4, sorry for the plus in there, then it was equal to the number of edges plus 2. So 8 plus 6 is equal to 12 if I add 2. And 6 plus 8 is equal to the number of edges if I add 2. And 12 plus 20 is equal to the number of edges if I add 2. Okay, so this pattern is known as Euler's theorem. I know you want to say Euler, but it's actually pronounced Euler. Like if you remember way back the Houston Oilers, who became what, the Tennessee Titans? Anyway, so the formula is, I take the number of faces plus the number of vertices, and it is equal to the number of edges plus 2. All right, so let's look at Euler's theorem here. So this, and it holds true for any polygon. It doesn't have to be any polyhedron. It does not have to be A Platonic solid doesn't have to be regular. It can be all funky like this. If I find the number of faces, vertices, and edges, then Euler's theorem holds true. So let's talk faces. Well, there's one face here in the front. There happen to be two in the back, so that's 3. And then if we go around, 4, 5, 6, 7, 8, 9. So my figure here has 9 faces. If I count vertices, I've got 1, 2, 3, 4, 5, 6, and then in the back, 7, 8, 9, 10, 11, 12. All right, and then let's count edges. So I'm going to actually mark off the edges to show that I've counted them, because otherwise it gets a little confusing. So 1, 2, 3, 4, 5, 6. That's around the front. And then we'll go around the lateral faces. 7, 8, 9, 10, 11, 12. And then 13, 14, 15, 16, 17, 18, and then this last one back here is 19 edges. And so if I check it, I take my faces plus my vertices, and it equals my edges plus 2. And I get 21 equals 21. So you can see that it holds true not only for the Platonic solids, but for all polyhedrons. All right, back to our buddies, the prisms. A prism is a polyhedron with 2 congruent parallel bases. And a prism is named for the shape of the base. So the prism has 2 bases. The rest of the faces are called lateral faces. And an altitude of the prism is a perpendicular segment that joins the planes of the bases. We also call this altitude a height. This is all information that you should have learned in middle school, which is why I've been using it already in the notes. All right, so the length of my altitude is called the height. And then in a right prism, which are the only ones we're going to be dealing with in this unit, the lateral faces are rectangles, and a lateral edge is an altitude. And we already talked about the formulas. The formula to find the lateral area of a right prism is the perimeter times the height, where P is the perimeter of the base. The formula to find the surface area, or the total area, is that lateral area plus 2 times the area of the base. And then the formula to find the volume of a prism is the product of the area of the base times the height. You need to memorize these formulas. I found that the easiest way to memorize the formulas without having to resort to flashcards or any other specific thing is to just write them every single time you do a problem. Okay, so I'm going to find the lateral area, the total area, and the volume of this figure right here. So to find the lateral area, I need to know the perimeter times the height. To find the total area, I need the perimeter times the height plus 2 times the area of the bases. And to find the volume, I need the area of the base times the height. Okay, so I've written these, and now I need to find all these pieces. Well, in many prisms, it's very obvious what the bases are. It's the things that there are 2 of. But in a rectangular prism like this one, there's 2 of everything. So that doesn't really help. So we need to identify a base. We mostly do it by having one of the sides shaded, but in this figure, nothing's shaded. So I'm going to go ahead and I'm going to identify the base for you, and we're going to use this as the base. It doesn't matter for the volume and the total area. Those don't change, but for the lateral area, it does matter, because the lateral area does not include the area of the base, so whatever you indicate is the base is going to affect what the lateral area is. All right, so let's find all these pieces that we need. We need P, and we need H, and we need B. Well, P is the perimeter of the base. If this red area is the base, then I do 2 times 8 plus 2 times 5 because it's a rectangle. So it's the area of a rectangle. So that's 16 plus 10, so that is 26. My height is the distance between the bases. So this edge is going to be my height. So my height is 6. And then B is area of the base. So area of a rectangle is length times width, 5 times 8. So that is 40. So now we go back and we fill in all of our pieces. So my lateral area is going to be my perimeter times my height. And when I actually do this multiplication, I get 156, and the units will be meters squared because it is area. Again, units are very important in this. Okay, so my total area is going to be that 156 plus 2 times the area of my base, which was 40. So 156 plus 80, which gets me, what is that, 236 meters squared again. And then my volume is going to be area of the base 40 times my height, which is 6. So 6 times 40 is 240, and that would be meters cubed because it is volume. All right, let's move on to the next problem. Okay, I would like you to solve this problem for me and come back when you have an answer. This time we're going to designate the top and the bottom as the base. So go ahead and solve this problem for me and come back and check your answers when you're done. Hit pause now. All right, so you should have gotten 130 meters squared for the lateral area, 214 meters squared for the total area, and 210 meters cubed for the volume. Your perimeter should have been 26, your height should have been 5, and your area of your base should have been 42. If you got any of those wrong, please try and figure out what you did. So sometimes we'll be given one of the measurements. For example, in this case, we're given the lateral area, and we need to find the other measurements from that. So again, we have got a rectangular prism, so this gets a little difficult. So let's go with this as the base, since they didn't indicate a base. And let's go ahead and find the height. So lateral area equals perimeter times the height. And the perimeter of my base is 2 times 4 plus 2 times 6. So 8, 12, 20. So my perimeter is 20. So 40 is going to equal 20 times the height. So height obviously is 2 meters. All right, so you go ahead and find the total area and the volume now. Come back and check your answers when you're done. Hit pause now. All right, so you should have gotten 88 meters squared for the total area and 48 meters cubed for the volume. For question number 4 here, I want you to give me the answer to that in the notes check. Okay. Works exactly the same way. This time you're given volume, so it's equal to the area of the base times the height. In order to help you out with lateral area, let's designate the side of this prism as the base. Okay, we're going to end part 1 of the notes here. Please be sure to go on to part 2.